Hello everyone. Today we can see the topic on the soil mapping, purpose of mapping, then methods of mapping, then fertilizer recommendations using the geospatial technologies. We can see the first concept of or the definition or meaning of soil mapping. First of all, we can see the what is mean by soil map. Soil map is a geographical representation showing the diversity of soil types and or the properties of soil, that is soil pH, texture, organic matter, depth of horizons in the area of the interest. Means you have to collect this information according to type of soil with respect to the properties, especially the soil pH, textures, organic matter content, and depth of horizons, with the help of the technologies, that is through GIS, GPS, as well as the remote sensing technology, which are used for the collection of the data regarding the diversity of soil types to evaluate the soil wise or the as per the soil type, soil pH, textures, organic matter, as well as depth of the soils should be studied with the help of the technologies. This is a concept of soil map. The soil maps are commonly used for the land evaluation, spatial planning, agriculture extension, environmental protection. The maps can be created especially in case of the soil as well as soil fertility, which can be mainly used for categorize or classify the land according to their use or utilization of the land. Then also the spatial planning means a specific area you have to use for the planning the different purpose, then also use for the agriculture extension, then also the environmental protection. Then soil maps are generally used for simplify to identify the size and their properties. The maps are generally used for also the general distribution of size. These are the in introduction part of the soil maps. Generally, soil maps are the important part to distribute the lands, to study the types of soils, to study the properties of soils, also to identify or to classify the soils needed for the evaluation of land and the spatial planning, as well as for choice of crops or cropping systems. Hence, there is need of the soil mapping. Then next one we can see the soil mapping is the process of the natural bodies of the soils, classifying, grouping of the soil into the map units and capturing the soil property information for the interpreting the soil spatial distribution on the maps. The soil mapping concept are generally used for to collect the information of the natural bodies of the soil present on the earth, which should be categorized or classified or grouping into the map units. The map units are generally used for classification and distribution or the identifying the properties as well as evolution of the land, and this information should be interpreted or manipulated with the help of the GIS or GPS technologies. And then finally you have to prepare the maps. That maps are useful for the uh, farmers to identify the soil type or to study the types of soil accordingly, pH, texture, structure, depth of horizons, and then finally accordingly you have to choose the crops for planting. This is the main purpose of or important objective of this soil mapping. Then soil mapping also provides uh, important information about the characteristics and the condition of land, which is used for the selection and selection of the crops and cropping systems, and also the to know the details about the soil pH, physical properties as well as chemical properties. Then also in this soil mapping there are different types of scales or these scales are used for the different levels and then for different purposes. First, we can see the soil maps at 1 raised to 2 like 50,000 scale. This scale provides the information regarding the planning at regional and state level. This scale, that is 1 is to 2 lakh 50,000 scale, and generally used for the national and regional levels. This is used for mainly to determine the suitability of land and the limitations of the land for generally several uses of the agriculture, and it requires less intensity of observation and time. Means this is a specific scale which is used for only in the regional and national level for the determining the suitability. How to check the suitability according to suitability, you can choose the crop or cropping systems, as well as the planning the crop production in this lands or the soil types, and whatever the limitations are observed accordingly the scale it should be follow the different agriculture practices. And these scales, that is 1 is to 2 lakh 50,000 scale, are generally requires less intensity of the observations and time. Then a second scale, that is 1 is to 50,000 scale, which we are used for the planning resource conservation and the optimum use at a district level. Means this scale is used generally at a district level for the only conserve the resources, especially natural resource base, and it requires the moderate intensity of observation. Then third one, that is large scale soil maps at the 1 is to 8,000 or 1 is to 4,000 scale, are used for specific purpose, which is used generally as a large scale level and for the specific purpose, and the intensity of the field observation is high than the uh, previous scales. These are the three main types of scales which are used in soil maps during the preparation of soil mapping. Next one, we can see the what is the purpose of soil mapping. First purpose, that is to synthesize the key properties of soil in a single document. Means we have to uh, uh, make the documents with the help of soil maps or soil mapping. You can use the different set of quantifications and lignins that allow the rapid interpretation of the results. We have to study these documents from for the different properties of the soils, as such as chemical, physical, and biological properties, as easy to analyze or synthesize these properties with the help of this document. That is the need or purpose of soil mapping. Second uh, purpose of soil mapping is to describe the distribution of soil units. Soil units are the part which were the more or less generalized or suitable for different scale levels. That is, we can see the earlier one, that is 1 is to 2 lakh 50,000, 1 is to 50,000, 1 is to 4,000, or 1 is to 8,000. These are different map scales are used for the distribution of the lands or evaluation of the lands at district level or national levels, as well as the for this special purpose, where can describe easily the different types of soils or soil units with the help of the soil mapping. Third purpose, that is to provide the graphic documents with which synthesize the inventory or and or the evaluation of the soil units. Means we have to produce the maps accordingly, collection of data, that is means different properties or the characteristics of soils. You have to make first the analysis of the data, they interpreted the data, presentation of the data, and final document uh, preparation. And after that, along with this data analysis, then we have to prepare the graphic representation to synthesize the evaluation of the land or the soil units which are used for the distribution all over the land in India or in the world, which is important purpose of the soil mapping. Then fourth one, that is to contribute the dissemination of knowledge about the soil and the spatial distribution and the properties. This is an important purpose of the soil mapping, that is to disseminate proper knowledge regarding the types of soil regarding the types of problematic soils, regarding the physical, chemical, biological properties of the soils, as well as the uh, soil types with their depth of horizons, and the accordingly choice of crops or the cropping systems. This should be disseminate easily with the help of soil mapping. And these soil mapping are used generally the spatial distribution, means specific area, whatever the lands are available, we can collect the data of the soil regarding the distribution of the crops or the different cropping systems, and then also study the specific area wise the properties of the soils. This is the spatial distribution. And then last one is the allow rapid access to soil information. This is a major one. With the help of soil mapping you have to assess the information, especially in terms of specific or visual or synthetic and the biodimensional representation of the soil of the specific area, that is spatial distribution. The soil maps can facilitate to assess or to provide easily information which will be used for the choice of crops or cropping system. These are the main purpose of soil mapping. Next one, we can see the what are the different methods are used for soil mapping. That is first one, visual image interpretation. In this visual image interpretation, where the different images are collected, whatever the images of the soil as per the spatial distribution or as per the specific area, then accordingly images should be interpreted or manipulated based on the shape, size, tone, shadow, texture, pattern, sight and association. These are the major and basic elements required for the visual image manipulation or interpretation, required for the distribution or classify or identify the soils according to their characteristics, according to their distribution, is needed for the choice of crops or cropping systems to be followed in a specific area or in a special uh, area. Then soils are also surveyed and mapped by the comprising the interpretation of remote sensing imaginary. This is the example of aerial photography. With the help of aerial photography, which are mainly used in remote sensing, that are used for surveying the soils, and whatever the data are collected, that data should be stored in the computer, which are should be interpreted, analyzed, manipulation, presentation, and finally disseminate that data. And whatever the data are analyzed should be converted into the maps, which are used for the uh, correct or the specific knowledge regarding the information of the soils. And this also is also needed for the field survey and the cartography. Then soil maps are generally uh, generated through the visual interpretation with the help of the satellite imagery. Then cartography. The cartography means the maps which are prepared with the help of the data, whatever the data are analyzed with the help of digital computer device. Their data are converted into maps. The maps are designed, then maps preparation or the map modification or changes of the maps, and finally marketing or sharing of the maps are the concept of cartography, which are mainly used for visual image interpretation, are needed for the soil mapping. Then second method, it is computer aided approach. In this method or approach, the computer mapping strategy, that is mainly the computer devices are mainly used for provide the efficient and accurate means of organizing, compiling, analyzing and displaying the complex interrelated data which are associated with the problematic soils, that is salinization or sodicity or the acidic soils, which are should be categorized or classified with the help of the computer technology, which should be compile data, organize data, analyze and the finally displaying the data with the help of computer aided approach or with the help of digital computer. The maps in this method, the maps can be easily made from the data to the land and irrigation management decision making. It should be there. Accordingly, maps are prepared in this computer should be used for only the irrigation scheduling or make the decisions proper regarding the land management as well as the irrigation management. These are the two common or these are the two important methods of the uh, soil mapping. Next one, we can see the what are the different geospatial technologies used for the soil mapping. That is first one GIS, that is geographical information system. Second one GPS, that is global positioning system. Third one, that is remote sensing. Then fourth one, site specific nutrient management. In that where there are different subpoints, that is selection of yield goal, assessment of crop nutrient requirement, then estimation of indigenous nutrient supplies in nutrient rates, and then finally study the dynamic adjustment of the nitrogen rates. You can see the one by one. That is first one, use of GIS, GPS and remote sensing for fertilizer recommendations. Then mainly in precision agriculture or precision farming, there provides the better management of natural resources with the help of technology, that is geographical information system, global positioning system and remote sensing, which are used to manage the natural resources by providing the data which were collected in a specific area. It should be analyzed, compiled, interpreted and processing or dissemination of this data which are used for the conservation and management of the natural resource. Then also you have to check the variability conditions from the each field regarding the nutrients variability, regarding the moisture variability, regarding the pH, then EC, CEC, AEC, as well as the bulk density, particle density, means physical chemical properties as well as biology property which can be evaluated their variability from the each field with the help of these technologies. Then also the fertilizer recombination or application is important part of in agriculture which were carried out for the efficiency and judiciously to ensure optimum returns from its investment, means whatever the nutrients are applied should be compared with their cost or their returns should be there, and finally total investments which are related with the which are correlated with their efficiencies of the nutrients are applied with the help of GIS GPS remote sensing technologies are used to accurate apply or precise application of these fertilizers in a specific location and in a actual quantity to ensure the efficiency as well as the proper returns with the less investment. This is a major use of this GIS GPS and remote sensing technologies. Then in case of the precision agriculture practices, we have to use the optimum soil resources to compensate the this technology, that is GIS GPS technology, which are used for a site specific crop management in a system in agriculture, that is majorly used for the to optimize the use, means what without wastage of the land the soil resource which can be utilized properly under or it should be crop under without wastage should be compensated with the help of the technology. Then also employed the increase the yield, then also reduce the production cost and minimize the their negative impacts on the environment with the help of technologies which should be increase the yield, reduce the production costs, means to use the minimize the use of agrochemicals, should apply the nutrients as per the need of the crops as in a specific location, helps to increase the crop yield and also minimize the losses of nutrients which should be reduce the impacts of or negative impacts of the environment. And with the help of GIS technologies or the GPS technology, we can check the variable parameters can affect the agriculture production. Then also evaluate the yield variability, physical parameters of the field, chemical property as well as physical property and crop variability with the help of the GIS, GPS and remote sensing technologies. This is needed for the major one, the fertilizer recommendation. The next one we can see the objectives of GIS, GPS and remote sensing. There is first objective to create the fertilizer variable rates maps, means you have to with the help of GIS, GPS, remote sensing. In case of GPS, only they collect the information with the help of receiver, antenna, and the major one the signals and the GPS. These are the different parts or the components of GPS. But in case of this GIS, whatever the data are received from GPS should be stored in GIS. GIS acts as a software which is used for the analysis, compilation, then representation or presentation, and then finally dissemination of the data and the preparation of these different maps accordingly variabilities of fertilizer or fertility of the soils. Second objective of the GIS GPS remote sensing is to decision support system to create the information from the foliar analysis to develop their foliar nutrient maps. Means we have to use the these technologies for the foliar spray or pesticide, then fertilizers or the growth hormones or growth regulators should be used as a uh, f- use as a efficiencies of their efficiencies to develop their the foliar nutrient maps. Then accordingly, a major objective that is size specific fertilizer rate requirements also can be estimated with the help of technology. Site specific fertilizer rates means whatever the nutrients are should be applied in a precise amount, right time, right method, in a right location. Should be there in site specific nutrient management. The main aim of this SSNM is should apply the fertilizers in a specific area in actual quantity in a proper method. Then also to maximize the yield through efficient use of the fertilizer inputs. Then finally, whatever the nutrient inputs or fertilizer inputs are applied to the crops should be as per the need of the particular crops, then increase the yield or maximize the yield as well as the efficiency of these fertilizer inputs. Next one, the you can see the benefits of GIS, GPS and remote sensing. By developing this GIS database of the particular area, the plantation information can be efficiently utilized for management, forecasting and planning. These are the major and basic benefit of GIS, GPS and remote sensing. With the help of this technology, we have to use the or collect the data of the specific area or spatial information. That data should be analyzed, compiled, interpreted, presentation or representation, and finally dissemination. And this, along with the database, we should plan the plantation program accordingly, efficiencies, and then forecasting this program, and finally uh, planning of this program with the help of technologies. Then in case of precision agriculture, these technologies generally are used to improve the agriculture practices, especially in the fertilizer applications, especially in tillage practices, sowing of the crops. Then in a livestock system also, the GIS, GPS and remote sensing technologies are used. Then also they give the information regarding the fertilizer rates maps to give the actual application of the fertilizers in the field in such a way that it will be optimize the fertilizer usage and maximize the yield production. Next one you can see the remote sensing in with integrate with the GIS, GPS can be used for to gather the information about the surface of the earth. Whatever the satellites or the sensors are used in the remote sensing technologies that can be used for to collect or gather the information. And also remote sense data can be used for mapping of the soil as well as yield mapping, yield growth mapping, or the soil distribution mapping. And also the spatial analysis is collected as the with reflect to the electromagnetic radiations, that is reflected electromagnetic radiations are the major part of the source of the remote sensing. With the help of the sun or the radiation or illumination of energy, we can receive the data whatever the objects are available on the earth should be there to collect the information directly by the satellite. Then satellite should be process this data with the help of images, the graphical presentations, and that data is useful for the mapping. Then also these remote sensing technologies are generally they are infrared, near infrared, then thermal infrared are the parts of rays are used in the electromagnetic spectrum, which is used for the uh, to classify the crops or discriminate the crops according to their length of uh, life cycle or according to their growth of stages or chlorophyll synthesis, which will be there according the absorbance of light in the strong absorb of the light, that is blue 0.48 nanometer, and the red, that is 0.68, and the near infrared radiations, that is 0.75 to 1.35 nanometer. The major water absorbent radiations in the infrared region should be there in 1.35 to 2.5 nanometer. Spectral properties of the vegetation in different parts of the spectrum can be also recorded with the help of reflector radiations. Means whatever the information should be collected in remote sensing, that should be there the major source, that is illumination of energy or the sun with the help of radiations. That radiations are reflected from the specific objects should be collect the information that or data. That data are stored in the satellites can be transfer the data to the computers should analyze data compilation, interpretation, dissemination, and finally preparation of the mapping with the help of computer. Then we can see the applications of GIS, GPS, and remote sensing. In this case, the main use or applications of these technologies are generally in individually or combination can be broad range of applications to avoid the degree of complexity in the system, and also used for the involving the location of the sampling sites, and then plotting maps for the use of field or examining the distribution of the soil types, and also with respect to yield levels and the productivity can be evaluated or uh, determining with the help of these technologies. Then also the more complex application can be taken with the help of this GIS and remote sensing softwares. Then also the visibility or crop classification for the predicting crop yield and their environmental impacts. And then also the surface water drainage patterns or the tracking animal migration patterns are also studied or classify in these with the help of these technologies. Then, in case of GIS is the Geographical Information System. Is a powerful tool for the collecting, storing, retrieving the data at will, transforming and displaying spatial information of the particular purpose. This is the main purpose, or this is the main use of this GIS. Then, ability of GIS is to analyze, visualize the agriculture, environment, and workflows, which would be provide beneficial to the farming industry. Then nowadays the GIS technology are the major essential tool for combining various maps as well as satellite information sources, which will be interact with the complex natural systems. GIS can be also used to produce the images, not just maps, but drawings, animations, analysis of data, as well as finally the cartographic products can be produced or can be prepared with the help of GIS technology. From the mobile, GIS in the field is to be used for scientific analysis of the production data in the farmer's manager office, which will be playing the major role to increase the agriculture production as well as increase the farmers yield, crop production level or yield of crops, then also reduce the cost and manage their land more efficiently. This is a major and basic information of the GIS. Then geospatial data collection, analysis and interpretation for the different agriculture purpose. That is the geospatial technology, that is GIS, GPS and remote sensing should be successful if the data is correct or the not collected or analyzed effectively. Then should they use the geospatial technologies which can achieve the uh, uh, larger efficiencies, or the basic is needed for the analysis of the data to satisfy the uh, uh, different parts or different needs of the farmer. Then especially needed for the precision farming. That is the main purpose of these geospatial technologies are used to collect the data analysis and the manipulation for the agricultural purpose. That is to collect the information regarding soil types, pH, pest infestation, nutrient availability, soil moisture content, fertility requirement, weather predictions, crop characteristics. Then different crop hybrids responses you have to be evaluated or analyzed with the help of these geospatial technologies. Then next point, there is site specific nutrient management, that is SSNM. It is a new approach for nutrient recommendations, mainly based on the nutrient supply, especially indigenous nutrients from the soil and nutrient demand of the crop for the achieving the target yield. Means in this concept, we have to approach the uh, nutrients or apply the nutrients based on the soil and the demand of the crop for achieving the target yield. Then this SSNM helps in improving the nutrient use efficiency, as it provides the feeding of crops like rice, maize, wheat with nutrients as and when needed. The major benefits for farmers to improve the nutrient management strategy as well as increase the profitability. Then SSNM eliminates the wastage of fertilizers by preventing the excessive rates of fertilization and avoiding the fertilizer application. This is a major objective of the SSNM, that is to avoid the wastage of the fertilizers for preventing the environmental impacts, as well as to avoid the excess or huge use of the chemical fertilizers. Then in case of the SSNM is a new concept which will be fundamental to precise the nutrient application in different crops. Means as per the need, should apply the fertilizers for achieve the target yield. Then the SSNM provides the need-based feeding of the crops with the nutrients, and this is a major part or main part use of the SSNM, that is as per the need or demand of the crops should apply or supply the crop nutrients. Then also used for the efficient utilization of the nutrient by crop plants to avoid the wastage of fertilizers, as well as to environmental footprints of the chemical fertilizers are also reduced. Nowadays the main impact of this excess use or huge use of the chemical fertilizers is the environmental quality is to be deteriorated or destroyed because of this huge use of the chemical fertilizers. But in with the help of this site specific nutrient management approach or technology, we can use the fertilizers as per the need of crops. And also if you increase the efficiency of the nutrients, helps to improve the soil quality or soil health, as well as the protect the environment from the different types of pollutions. Then for effective and efficient SSNM, use of soil and plant nutrient status with the help of sensing devices, that is remote sensing. Then GIS decision support systems